Hello students, today we shall learn lesson 13 chemical change and chemical bond. Whenever energy is supplied to matter that is absorbed by or removed from it, it undergoes a change. Changes that occur around us can be classified in various ways as natural or man-made, useful or harmful, quick or slow, periodic or non-periodic, physical or chemical change. All these changes you have learned in the previous standard. Now let us see what is a physical change. Here you can see some examples like melting of ice, boiling of water, dissolution of salt in water. In all these changes you can see the original substance remains as it is and no new substance is formed. Such changes are called physical change. Now look at these examples. The ripening of banana, potato which is cut open has become dark in color. Foul smell starts coming from spoiled food. These are all examples of chemical change. And during a chemical change, the composition of original substance changes to form a new substance with different composition and properties. Now let us try this activity. Take the lemon juice in a clean glass. Now take 2 drops of lemon juice in a spoon and taste it. We all know the taste of lemon juice. It's sour to taste. Add a pinch of baking soda in the glass of lemon juice. You will notice bubbling around the particles of soda. You will even hear sound if you take the glass near your ear. Now again try to taste it. You will see that the sour taste has become little mild. So in this activity, many perceivable observations are noticed during. A gas is seen to be liberated in the form of bubbles. Low sound is heard. White solid particle of baking soda disappears. And the original sour taste becomes mild or diminishes. From this, it is understood that a new substance having a different taste is formed. At the end of the above change, the taste of the substance was different means its composition was different. Thus, during the above change, the composition of the original substance changed to form a new substance with different properties. Thus, the change that takes place on adding baking soda to lemon juice is a chemical change. Sometimes, some characteristics observations are perceived during a chemical change. For example, if an apple is cut open, you can see it becomes dark after some time. Or if the food is not fresh, the taste changes. Or the iron nails, it rusts after some times. In all these changes, you can see there is a change in the color, taste, or release of gas. And these enable us to know that a chemical change has taken place. A chemical equation can be written for a chemical change if the exact change in chemical composition is known. Names and chemical formulae of the original substance and newly formed substance are used while writing a chemical equation. For example, when baking soda is added to lemon juice, a chemical change takes place in citric acid, which is present in the lemon juice, and the gas formed is carbon dioxide. The word equation can be written for this chemical reaction as follows. Citric acid, that is the lemon juice, plus sodium bicarbonate, that is your baking soda, giving carbon dioxide gas plus sodium citrate. So here acid plus alkali is giving carbon dioxide plus salt, which is an example of neutralization reaction. The same reaction can be written in the form of chemical equation. That is, citric acid, the chemical formula is C6H8O7. Sodium bicarbonate can be written as NaHCO3. Gives carbon dioxide, that is CO2, plus water is given, and sodium citrate, the molecular formula is Na3C6H5O7. So, the same reaction can be written in the form of word equation and chemical equation. Always remember, the first step of writing a chemical equation is to write a word equation by using the names of the concerned substances. When the chemical formula is written in place of each of the names, it becomes a chemical equation. While writing a chemical equation, the original substances are written on the left side and the newly formed substances are written on the right side, and the arrow is drawn in between. Arrowhead points towards the substance's form. Arrow indicates the direction of the reaction. Substances written on the left side of the arrow are original substances that take part in the reaction. They are called reactants. The new substance formed as a result of the reaction are called products. Place for the products of the reaction is on the right side of the arrow. Chemical changes in everyday life. We find many examples of chemical changes in our surrounding, body, home and laboratory. Let us see some chemical changes for which word and chemical equation can be written easily. We'll begin with some natural chemical changes, that is respiration. Respiration is a continuously occurring biological process. In this process, we inhale the air and exhale carbon dioxide and water vapor. After an in-depth study, it is learned that glucose in the cells react with the oxygen in the inhaled air to form carbon dioxide and water. The word equation and chemical equation of this chemical reactions are as follows. Glucose plus oxygen during respiration combines to give carbon dioxide plus water. And the chemical equation of this will be, the molecular formula of glucose is C6H12O6. Oxygen, that is O2. The condition, that is this is happening during respiration to give carbon dioxide, that is CO2 plus water, that is H2O. The next natural chemical change is photosynthesis. We all know photosynthesis is a process in which green plants prepare their food in the presence of sunlight and chlorophyll. The word equation for this will be carbon dioxide plus water in the presence of sunlight and green plant gives glucose plus oxygen. The chemical equation will come as carbon dioxide, that is 6CO2 plus water 6H2O in the presence of sunlight and green plant giving glucose. The molecular formula is C6H12O6 plus 6 oxygen molecules. Man-made chemical changes. We bring about many chemical changes for our use in everyday life. Let us see some of them. The chemical change that we saw in the first activity is used in cold drink called soda lemon. It means that it is an useful man-made chemical change. Let us learn some more man-made chemical changes like the combustion of fuels. Wood, coal, petrol or cooking gas are burned for getting energy. The common substance that burns in all these fuels is carbon. During the combustion process, carbon combines with oxygen in air and the product carbon dioxide is formed. A common equation can be written for all this combustion process as follows. Carbon plus oxygen giving carbon dioxide. And the chemical equation can be written as carbon C plus oxygen O2 combining to give carbon dioxide, that is CO2. And combustion of fuel is a fast and irreversible chemical change. Cleaning Shahbad tile with dilute hydrochloric acid. The chemical composition of Shahbad tile is mainly calcium carbonate. During its cleaning with hydrochloric acid, the upper layer of the tile reacts with hydrochloric acid and three products are formed. One of them is calcium chloride, which being soluble in water gets washed away with water. The second product is carbon dioxide. It bubbles, mixes up in air. The third product, water, mixes with water. The following equation can be written for this chemical change. Calcium carbonate plus hydrochloric acid gives calcium chloride plus carbon dioxide plus water. And the chemical equation can be written as CaCO3, that is calcium carbonate, plus HCl, that is hydrochloric acid. They both combine to give CaCl2, that is calcium chloride, plus 6CO2, that is carbon dioxide, plus H2O, that is water. Softening of hard water. What is hard water? The water in which soap does not lather is called hard water. Some wells or tube wells have hard water. It is brackish to taste and does not form lather with soap. This is because of hard water contains the chloride and sulfate salts of calcium and magnesium in dissolved state. To soften the hard water, a solution of washing soda is added to it. This results in a chemical reaction to form a precipitate of insoluble carbonate salts of calcium and magnesium. As the dissolved salts of calcium and magnesium go out in the form of precipitate of the carbonate salts, the water is softened. The following equation can be written for this chemical change. The word equation will be calcium chloride plus sodium carbonate giving calcium carbonate plus sodium chloride. And the chemical equation for this will be CaCl2, that is calcium chloride, plus Na2CO3, that is sodium carbonate. They combine to give CaCO3, that is calcium carbonate, plus NaCl, that is sodium chloride. Chemical bond. We saw that composition of matter changes during a chemical change and a new substance having different properties are formed. When this happens, some chemical bonds in the reactant break and new substances called products are formed by formation of a new chemical bond. Noble gases do not form any chemical bond as their electron octet or duplet is complete, while the atoms with incomplete electron octet or duplet forms chemical bonds. Reason for this is that an atom uses its valence electron during the formation of a chemical bond. Moreover, on forming chemical bonds equal to its valency, the atom attains the electronic configuration of complete, octet or duplet. Chemical bonds are of two types, that is ionic bond and the covalent bond. The chemical bond formed due to an electrostatic force of attraction between the oppositely charged cation and anion is called an ionic bond or an electrovalent bond. The compound formed by means of one or more ionic bonds is called ionic compound. Formation of an ionic compound sodium chloride from the elements sodium and chlorine is shown in this diagram. Now let us try to see how this ionic bond is formed. Sodium, which has the electronic configuration as 281, see how the electrons are distributed. 2 electrons in the first shell, 8 in the second shell, and in the third shell it has 1 electron. So it has this 1 electron which has to be removed so that the octet can be complete. Whereas chlorine, which has 17 electrons, so 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the third shell. So chlorine requires 1 electron to complete its octet. So here sodium donates its 1 electron, whereas chlorine accepts 1 electron, and a bond is formed between them. When sodium donates this 1 electron, it becomes sodium ion, and when chlorine accepts this 1 electron, it becomes chloride ion. And when they combine together, sodium chloride ion is formed. Now let us see the formation of ionic bond in magnesium chloride molecule. Magnesium chloride, which is formed by one magnesium atom and two chlorine atoms. Chlorine, which has 17 electrons, is distributed as 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the third shell. So chlorine requires 1 electron to complete its octet. Whereas magnesium, which has 12 electrons, is distributed as 2 electrons in the first shell, 8 electrons in the second shell, and 2 electrons in the third shell. So these 2 electrons are extra which has to be given away so that its octet can be completed. Again one more chlorine which has 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the third shell. So here this chlorine also requires 1 electron. So magnesium donates one electron to this first chlorine and 1 electron to the second chlorine, and an ionic bond is formed between magnesium and chlorine. So chlorine, after accepting the electron, becomes chloride ion. Magnesium donates 2 electrons and becomes Mg2 plus, that is it has donated 2 electrons. Then this chlorine which has accepted one electron becomes chloride ion. So a ionic bond is formed between magnesium and chlorine molecules. Covalent bond. The chemical bond formed by sharing of valence electrons of two atoms with each other is called a covalent bond. One covalent bond is formed by sharing of two valence electrons. Generally, a covalent bond is formed when atoms of two elements having similar properties combine. Such atoms cannot exchange electrons. Instead, these atoms share electrons with each other. The shared electrons become a common property of both the atoms, and thereby the electron octet or duplet of both the atoms becomes complete. Now let us consider the example of hydrogen molecule. A hydrogen atom contains one electron. Its duplet is short of one electron, and therefore the valency of hydrogen is 1. The two atoms of hydrogen are identical and have similar tendency, and therefore they share the electrons with each other. As a result, the electron duplet of both the hydrogen atom is complete and a chemical bond is formed between them. Now let us see how a water molecule of a covalent compound is formed from hydrogen and oxygen atoms. Just look at the figure. There are 6 electrons in the valence shell of oxygen atom. It means that the electron octet in oxygen is short of 2 electrons and the valency of oxygen is 2. In the water molecule, the oxygen atom completes its octet by forming two covalent bonds, one with the two hydrogen atoms. While this happens, the duplet of the two hydrogen atoms are also completed.